Okay, so now we're going to use what we learned about Venn diagrams to do an informal proof of DeMorgan's law. This law will be used in logic as well. All right, as we did before, the first thing that we will want to do is number our regions. Okay, so it looks like they want the complement of the union of A and B. Well, remember that the union of A and B is going to be all of set A or set B or what's in both. Okay, so that would be regions 1, 2, and 3. But remember, we want the complement of that, so that means we're going to shade region 4. Okay, well, let's do that real quickly. Okay, so now let's look over at this next one. So they want the intersection this time of the complement of A and the complement of B. Well, let's again start by numbering our regions. So the complement of A is everything that's not in set A. So complement of A would be regions 3 and 4, right? And the complement of B is going to be everything but regions 2 and 3, because regions 2 and 3 make up set B. So that would be 1 and 4. Now, since we're looking for the intersection, we only want what they have in common, right? So it looks like region 4 is the only thing that they have in common. So that means that we're going to shade region 4 again. So that should give you cause to reflect that these two expressions are represented by the same Venn diagram. So maybe they might be equivalent. Okay, well, let's look at the next two. So again, let's number our regions. So I want the intersection of A and B, but the complement of that. So the intersection of A and B is just region 2. So it's what they both have in common, but I want the complement of that. So that means I will be shading regions 1, 3, and 4. So I'll be shading everything but region 2. So let's do that real quickly. Okay, and perhaps you can predict what will happen next. So let's number our regions. So we need the complement of set A. So remember, the complement of set A was regions 3 and 4. And we need the complement of set B, and that was regions 1 and 4. This time we need the union of all of those. So it looks like we'll be shading regions 1, 3, and 4. So we'll be shading everything but region 2 again. All right. So what conclusions can you make from the pattern shown above? Well, it's quite possible that the complement of the union of A and B is the same as the intersection of the complement of A and the complement of B. And similarly, the complement of the intersection of A and B is equivalent to the union of the complement of A and the complement of B.